Section 14.4, applications for trig equations. Trig is the study of anything that cycles up and down, back and forth, or rotates. So one such example is about oceanography on page 932. This is the model, notice, is given to us. So where we're going to head next time is where we read the situation and we actually have to find this model. But the model is actually given to us, and all we have to do is solve it and then answer a question about it. So this, at this stage, we still have it easy. So if you look, the context for this problem is here, and then we'll solve it together. We'll write out the solution together. So the context is the water depth. Water depth D is given by D. Notice it's nice when the variables are defined for you, so you know what the model means. Water depth D for the Bay of Fundy can be modeled by this equation. D is measured in feet, and T is the time in hours. If T is 0, represents midnight. That's helpful to know. That 0 represents midnight. At what time is the water depth 7 feet? So here's a picture of, wow, look at the difference between low tide and high tide. Their pants would be wet if they were standing there at high tide. Alright, so we're going to solve this and answer the question. Remember, the question is, at what time is the water depth 7 feet? Okay, so here we go with our equation. So we'll solve this together. We want to substitute 7 in for D, so that's our first step. 7 equals 35 minus 28 cosine pi over 6.2 times T, the time in hours. And pi over 6.2 is just a number, mind you, because pi is just a number 3.14, and that's 6.2. This is just a number. Okay, so time in hours, and we're going to solve for T as our goal. It is so tempting to take these numbers right here and subtract them. Doesn't it look tempting, like you could just do 35 minus 28? You cannot, because this number is attached to this. There's 28 of these things, and you're subtracting all of them. You can't just take these and separate it. It doesn't follow order of operations anyway. PEMDAS, parentheses, exponents, multiply and divide comes before adding and subtracting. So if you just followed PEMDAS, you would not subtract before you would multiply. Okay, so let's not do that. That would be the most common mistake. So what we're going to do instead is we're going to do it the right way. We do want to get this T alone, so we do want to get rid of these other things. So let's start by getting rid of the 35. Rule of thumb is start furthest away from T. Furthest away, meaning this is not attached to this at all. So subtract 35, so you get negative 28 equals, that right? Yeah, negative 28 cosine of some number, pi over 6.2 T. And we still want to, now we want to get rid of the negative 28, so divide by negative 28. See, that's very different than what we could have mistakenly done. So that's just a nice 1, a nice number 1, 6.2T, great. Okay, so then do we want to get rid of this? Do we divide by cosine of, no, that wouldn't make any sense. But we can take, what you want to do to find this right here is take the inverse. So where is the cosine 1 is what you're asking yourself. So we can say pi over 6.2T equals the inverse cosine of 1. Okay, so where is the cosine 1? So what is this equal to? Inverse cosine of 1. Where is the x-coordinate 1? You really have to, picture your unit circle. Where does that happen? On the x-axis right here, right? And so for every interval, if we want all the solutions, every time we're here, that's the only place it happens, right? The coordinates are 1, 0 right there in our unit circle. coordinates are 1 to the right 1, up 0. The x coordinate is 1. So if we want all of our solutions, so it's 2 pi n, or 2n pi. So every multiple of 2 pi, we will get around to that place. Okay? So we have pi over 6.2t equals 2n pi. And so, so we want to solve for t. Did I start writing this down there? Sorry. That's just t. So t is 2n pi over 6.2, which is the same as multiplying by the reciprocal when you divide by a fraction. So the pi's will cancel, and you get t equals 12.4 n. So n could be 0. It could be 1. We know value. So, well, we're not done, right? So let's not circle that. We still need to answer the question. So let's answer it in a complete sentence. The water depth is 7 feet. The water depth is 7 feet. At what time or times is it? It happens a lot, right? Because it's cyclic. So if n equals 0, what's the time? Using this expression, time is 12.4 times 0, which is 0. So that's midnight, right? Because it was defined. Time 0 is midnight. So it happens at midnight, but it also happens, and we're going to make the integer n be equal to 1. Because number n is the number 0, 1, 2, 3, etc. If n is 1, we have 12.4 times 1, which is just 12.4. So we just need to translate that into a time. So that's at what time? That's 12.4 hours after midnight. Is that 12:40 p.m.? No. So be careful. It's 12 something. 0.4 of an hour. How many minutes? So we have to take. That's like 4/10, right? So 24, right? So 12:24 p.m. So we have to take 60 and multiply by 0.4. So you get 24 minutes, which is 12:24 p.m. So now, does it happen again? Yeah. So when n is 3, but that will be past, we just want all the times it happens within a 24-hour time frame. So it's midnight and 12:24 p.m. And we could keep going. We could plug in n is 3, etc.